Hello students, in this video we're going to go over the data analysis section of your final report, in particular the correlation part. So here we're going to calculate the Pearson product correlation and determine if there is a relationship, significant relationship between those two pairs of questions. So we're dealing with interval or ratio measurement scales. We're going to take a little bit of poetic license and use perhaps some ordinal data that could be assumed to be interval. So let's go to our data. Here we're going to go to the coded section. The coded sections have been coded numerically for various questions. I have questions 17 to 23 as well as questions 7 to 11 coded on the summary survey results spreadsheet that I had sent out to you. So these questions that have numbers coded in for them, these are questions that you could actually run the correlation test for. So let's go down to the bottom. So you may have some of this. I've calculated the count, average, median, standard deviation for these 7 questions. You can do the same thing for questions 7 through 11 as well. Let's go to a Jamboard here, and we're going to just explain the correlation test. So it is an hypothesis test, like you have done or are doing currently in statistics, where we compare, we compare values from different populations or samples. So the null hypothesis is the claim. The null hypothesis is that the correlation, written with a funny looking P, is 0, that there is no correlation between the questions. The alternate hypothesis, HA, is that the correlation does not equal 0, which means then that there is a significant correlation. So if the decision is to reject the null hypothesis, we're left with the alternate hypothesis stating that the correlation is not 0. A 0 correlation basically means that there is no significant relationship. So this is a two-tailed test. We test our claim against level of significance of 5%. The test procedure uses a t-distribution value, so we have a critical value denoted as T alpha with n minus 2 degrees of freedom. N would be the number of pairs of observations. And we also then have a test statistic. This is the one we calculate. The calculation is R, which is the correlation coefficient of the two data sets, times the square root of n minus 2 divided by the square root of 1 minus r squared. That will give our test statistic. We then can compare and make our decision based on this decision rule to reject the null hypothesis if the test statistic is greater than the critical value. We can also make our decision based on the p-value. Reject the null hypothesis if the p-value we would get from that test statistic value is less than alpha. I'll make this a better looking alpha. There we go. So let's go into our data we have. We're going to run a correlation test. We're going to calculate the Pearson correlation coefficient, which is in Excel equals Pearson bracket, highlight one of your columns, comma, highlight the other column, and we get oh, what happened there? Oh, an extra comma. Don't do that. Took everything out. So that's AC3 colon AC122. There you go. Look at that correlation right there. Let's narrow that down a bit. We know from statistics that value more than 0.76 or more than 0.7, would be a strong correlation. So good chance that there is a significant relationship between these two questions, that they are correlated. So let's go into the process to calculate this. 0.7633. Let me write that down. 0.7633. Go to our tab here. We can find, or we can calculate that. We can calculate the test statistic. Now we have our 0.7633. We have 117 pairs of data divided by the square root of 1 minus 0.7633 squared. This turns out to be 12.668. That's our test statistic. We need now to find our critical value. Critical value is going to be based on half of alpha, 0.25. Degrees of freedom is going to be 117 minus 2, which is 115. So generally go to our t-distribution chart, which you remember from statistics. Here it is. We're going to be looking at this column, but we don't have 115 degrees of freedom. We know it's going to be, a little bit more than degrees of freedom 120, 1.98. So I have created this sheet that you can use. I'll make this available. Let's blow this up a bit. Let's find our critical value. We're doing hypothesis testing here. 5%, sample size 117, two-tail test. There is in yellow, our critical value, 1.981. This is the value we need. We only need that sheet because our sample size is more than that sheet allows us. So now, if we look at, let's change colors here. If we look at our test statistic and versus our critical value, these two things are, the test statistic is greater than our critical value. 12.668 is greater than 1.981, so we would reject the null hypotheses. Which means that there is a significant correlation between those two, the data 17 and 18. We can also go and find our p-value if you wanted to report that, and it's a good decision to report your p-value. So here we enter our test statistic, the one we just calculated, 12.668. And our our sample size, 117. And there is our p-value for a two-tail test. Bunch of zeros. This is the one that we would report right in there. 1.28e, negative 23. So our p-value (1.28e) negative 23. My memory is good, but really short. 128e23. So basically this e negative 23 means we have to, if you want to write this p-value in regular terms, we'd have to, where's my pen? We'd have to move the decimal place over to the left 23 times. So that's why there's going to be like 0.22 zeros, then 1.28. So it's really small. So therefore, we are also going to make the decision to reject our null hypotheses. Let's just make that a better looking value. This is our p-value. So I would recommend reporting it just as it's written there, 1.28, negative 23, E negative 23. So that's the process for a two-tail test. On your report, you could tell me what you're doing in the body of the report, comparing questions 17 and 18, for example. You get a p-value of 1.28 E negative 23, which basically means that you have enough evidence to state that there is a significant relationship between the data in question 17 and the data in question 18. If your decision is the opposite, basically do not reject the null hypotheses, you have determined, or you fail to reject the null hypotheses. You don't have enough information to say that there is a significant relationship. In your appendix, basically everything you see on this page could be written there as an appendix. Perhaps a little neater than what I have drawn. So that's for questions 17 and 18 for your survey results. If you are using questions 17 and 18, I would do another one as well, because I just don't want you including the work that I've done in your report, especially without citing me. So that is the correlation test process. I'll make this spreadsheet available and this video available for you.